TDistribution Class. This article gives the source code for a nice, clean implementation of a class to compile the discrete, cumulative distribution function of a sample data set. The CDF forms the basis for basic descriptive statistics. This article originally appeared in the Unofficial Newsletter of Delphi users, TDistribution Class. This article gives the source code for a nice, clean implementation of a class to compile the discrete, cumulative distribution function of a sample data set. The CDF forms the basis for basic descriptive statistics. TDistribution will automatically add bins to the CDF as data elements are accumulated, or you can predefine the bin boundaries before analyzing a data set. This auto-expansion of the CDF bins works best with sorted data sets, but for cool sorting components see http://www.kinix.com/tober/sorting.htm. In most cases it will work reasonably well without pre-sorting your data. The class descends from TStringList, so you can use the strings property to define a text string describing each bin, e.g. string 0 : Jan, string 1 : Feb. String 11 : dec. Thus the class flexibly supports your implementation within a variety of user interfaces. Note that this is not a user interface component, it is merely a class that provides a specific, statistical functionality. It's up to you to implement the user interface appropriate for your particular application. The class provides properties for estimating the sample data total and mean, based on the CDF. An example project is also included. Class for developing discrete, cumulative distribution function. Copyright 2000, Berend M. Tober. All rights reserved. Author's email, mail to btober@computer.org. Other components at http://www.kinix.com/tober/delphi.htm. Unit CDF, the cumulative distribution function, CDF, for continuous, real random variable x is defined as a function f, x, where f, x, equals p, x. The discrete case is similarly defined. The TDistribution class is used to generate an empirical CDF for a given data set by counting the number of values from the sample data set that fall into one of a set of discrete bins. This way you can quickly get a quantitative picture of a data set. The class descends from TStringList, so you can use the strings property to define a text string describing each bin, e.g. string 0 : Jan, string 1 equals feb, string 11 equals dec. Interface uses classes. Type TDistribution item equals class, TObject, private fben, double, upper limit of ben fcount, long int, public constructor create, value, double, count long int, function accumulate, value, double long int, property ben, double read fben, property count, long int read fcount, and TDistribution equals class, TStringList, private function getMean, double, function getTotal, double, public constructor create, destructor destroy, override. Procedure clear, function accumulate, value, double long int, function addObject, const s, string, aObject, tObject integer, override, procedure free objects, procedure put, index integer, const value TDistribution item, function free object, index integer, function get, index integer TDistribution item, property mean, double read getMean, property objects index integer TDistribution item read get write put, property total, double read get total, and implementation constructor. TDistribution item dot create, value, double, count long int, begin inherited create, fben equals value, fcount equals count, and function TDistribution item dot accumulate, value, double long int, begin result equals -1, if value then increment count of ben when value begin inc, fcount, result equals fcount, and constructor TDistribution dot create, begin inherited create, and destructor TDistribution dot destroy, begin clear, inherited destroy, and function TDistribution dot addObject, const s, string, aObject, tObject integer, add a ben to the CDF, in proper order var I integer, begin find where to insert new ben. This is just before the smallest ben which exceeds size of new ben. Result equals count, if count 0 then for I equals pred, count, down to 0 do if TDistribution item, aObject, dot ben then result equals I, if result then result equals inherited addObject, saObject, if no such ben, append new one else insert object, result saObject, insert new ben before next biggest end, function TDistribution dot accumulate, value double long int, count this data value into the CDF var I, long int, begin if count equals 0, then add object TDistribution item.create value 0 must have at least 1. Bin else if value object spread count bin, then if value exceeds largest bin, then add new one that is big enough, add object TDistribution item.create value object spread count for I equals 0 to pred count do result equals objects I.accumulate value and function TDistribution.get index integer TDistribution item begin result equals TDistribution item inherited objects index and function TDistribution.free object index integer begin result equals -1 if index equals count, then exit. If objects index nil, then begin objects index.free objects index equals nil and delete index. If index equals count, then result equals pred count, else if count equals 0, then result equals -1 else result equals index and procedure TDistribution.free objects var I integer begin if count 0, then for I equals pred count down to 0 do free object I and procedure TDistribution.put index integer const value TDistribution item begin inherited objects index equals value and procedure TDistribution.clear begin free objects inherited clear and function TDistribution.get total double. This is an estimate of the actual sample total var I integer begin result equals 0 if count equals 0, then exit result equals objects 0.bin objects 0.count for I equals 1 to pred count do result equals result plus objects I.bin objects I.count objects pred I.count. This is an alternative way to compute total result equals objects 0.bin asterisk objects 0.count for I equals 1 to pred count do result equals result plus objects I.bin plus objects pred I.bin asterisk objects I.count objects pred I.count result equals result /2.0 and function TDistribution.get mean double. This is an estimate of the actual sample mean begin result equals 0.0 if count 0, then result equals get total / object spread count and example implementation program example uses WinCRT CDF const data 1, array 110 of real equals 66, 73, 73, 81, 81, 81, 81, 85, 85, 89. Note: this data set is pre-sorted. TDistribution will still work with unsorted data, but you might not get a good CDF unless you predefine the CDF bins. This is especially true if the first element of the dataset happens to be the largest. Try it by rearranging the above data set, because automatic addition of bins will add a single bin into which all data will be counted. var ijword, begin with tdistribution.create do begin for I equals 1 to 10 do accumulate, data 1 I, writeln, mean equals, mean 6:4, writeln, total equals, total 6:4, print out quantitative summary for I equals 0 to pred, count, do writeln, objects I.bin 6:2 #44 objects I.count #44 objects I.count / objects pred, count, count 6:3, print out crude histogram for I equals 0 to pred, count, do begin for j equals 1 to trunc, 40 objects I.count / objects pred, count, count, do write, writeln, end, free, end.